So we're going to look further into compounding interest and see when you have to compound a whole lot over a long period of time, what that looks like, how to do that easily. So what you've seen already in terms of compounding interest, let's look at this example. Let's say we got $10,000 that's earning 8% annual interest, and that compounds quarterly. And it's sitting somewhere for 20 years. We're not going to touch it for 20 years, 8% compounding quarterly. So as you saw what to do with the simple interest formula, we would take the principal, 10,000, multiply by the interest rate, 8%. And then here's quarterly, right? 3 months out of 12 months would be 1/4 of a year. 1/4 of a year is quarterly. And that would be $200 of earned interest. So you can add that on. And now you have 10,200. Well, that's our new principal. That's how compounding works, right? We use the new principal for each compound. So we're going to take that and put it here and do the 8% for a quarter of a year. Again, that's 204, and we'll add that on. And now we'll have a new principal. And then we got the new principal times 8% quarter of a year. That's 20808. Add that on. We have the new principal. Now you can see that's kind of a lot of work, right? We've only compounded 3 times. We're not even done with year 1, and we got to do this for 20 years. That is going to be a long time, right? And in fact, if it's happening 4 times a year for 20 years, then it's going to happen 80 times, right? So I'd have to do this calculation 80 times. Well, we obviously don't want to do that. But this is this is what's happening. We're getting an interest, adding it on, using the new principal. Interest, adding it on, using the new principal, and so on. Well, how do we do that a little bit more easily? We can use the compound interest formula, and it looks like this. So this says that the future value is the principal times 1 plus the rate divided by the number of times per year that the interest compounds, all to the exponent of n times t, t being the number of years, and n, of course, again, being the number of times it compounds in a year. Where does this come from? So the first part of this video, I'm going to show you where this comes from and what's going on with this so you understand what the heck this formula is, and then we'll do a few examples. So, of course, this is just future value. What we're going to do, this idea here, we've got the 10,000, right? We've got the 10,000. And then how do we grow by 8%? You just did that by finding the growth factor in this case, right? The growth factor is our original 100% plus the 8%, right? So 108%, that's 1.08. That would be our growth factor, right? Well, that's where this comes from. This right here is the growth factor. We've got the 1, which is the 100%, and we've got the rate as a decimal, which is the 8%, right? The only difference is here that we would divide this by how many times it's happening in a year. How many times does it compound in a year? So we get the 100% plus the 8%. And then we divide it by how many times it's happening in a year? It says compounding quarterly, so we're going to divide it by 4, right? We're going to divide it by 4. And what that's doing is just splitting that up because we're not getting the full 8% for the year. This is a yearly thing, so you will not get 8% each time. This is not what's happening. Just because it happens quarterly, you're not getting 8, 8, 8, and 8. That would be wild, right? This is an annual interest rate. This says annual. The interest rates are going to be annual. So when this compounds quarterly, what's going to happen is actually it's going to split it up 4 times. And you're going to get, divided by 4, you're going to get 2% each time. So you can see this is the annual. So if I get 2, 2, 2, and 2, that's 8 total for the year. So 2 for the quarter, 2 for the second quarter, 2 for the third quarter, 2 for the fourth quarter is 8% annually. So that's all it's doing. It's taking the 8%, it's dividing it by the times it happens each year, and that'll give you that amount. And if you remember, we said, how many times is this going to happen? How many times is it going to compound if we're compounding quarterly for 20 years? Well, quarterly is 4 times a year. 20 years, that would be 80 times, right? So we need this to happen 80 times. Okay, an exponent. Remember that an exponent tells you how many times to multiply by something. So if we have like 2 to the third, that's 2 times 2 times 2, right, which is 8. It's just telling you how many times to take this base and multiply it. So essentially what we're saying here is we're going to take the 10,000 and we want it to grow by 8% quarterly, how many times? We want it to happen 80 times, right? We want it to happen 4 times a year for 20 years. And that's just telling you how many times to multiply. And that's all that's happening here. And we can get a finished product. Again, this is the principle. This is the growth factor. We're multiplying by 1.02 because it'll be 2% each time. That 0.08 divided by 4 is going to be 2%. So we're multiplying by 0.02 80 times. So it's going to grow by 2% 80 times. That's what's happening. And that'll give you $48,754.39. So 8% annually, compounding quarterly, and that'll give you that amount. So let's go through. I'm going to give you a few examples here.
We've got 10,000 earns 7.5% semi-annually for 10 years. Okay, here's what I think we should do. We're going to write out the formula, 1 plus r over n to the nt. Okay, and then we're just going to list these things. What do we have? This is going to make it easier for you, especially when what you're given is getting kind of mixed up, which we'll talk about next week. But we don't know this. This is what we're looking for. The primary or the original amount was $10,000. The rate was 7.5%. Now the rate has to be a decimal. So 7.5% as a decimal is 0.075. So I always put R as a decimal. And then N says semi-annually. That means twice a year. So that's going to be 2. And T is 10 years. Okay. We can just go through and put that then. So 10,000. It grows at 7.5%. So 1 is the 100%, 0.075. It's happening twice a year, so we have to split it into 2. And then it happens for 10 years, but it happens twice a year, so I multiply that by 2. Okay, so you could rewrite this if you wanted, but you really don't have to. You can go straight to the calculator, dump it in the Desmos calculator, and it's going to give you what you need. Now, I just realized that I didn't give it permission to see my whole screen, so I'll just add that in at the end. If you need to know how to put that in the Desmos calculator, go to the end. But we'll move on. I'll put the final answer, and then we'll move on to the next equation. So it is $20,881.52 for that one. And one more, and then I'll show you how to use the calculator too. $300. So again, we're going to have the same kind of things. R, N, and T. We have $300 to start with. The rate is 12%, but we want it as a decimal, so 0.12. Compounding quarterly, that means N is 4. It happens 4 times a year and for 15 years. So we can plug those guys in. 300 times 1 plus 0.12 over 4 to the 15 times 4. So 100% plus 12%, but the 12% split into 4 since it's happening 4 times a year. And then we want it for 15 years, but it happens 4 times a year. So we multiply that by 4. We toss that in a calculator, and we get this. So I guess I'll stop it, and I'll start the new one. Okay, so I would go to Desmos, and you're going to plug this guy in, whatever you have. We had the original 300. And we open parentheses to say that we're multiplying. So it's 1 plus 0.12 over 4. So we say 1 plus 0.12. And then, whoops, that is not in the parentheses. 1 plus 0.12. To put this over something, we hit the backslash button. It's the one with the question mark, backslash, puts you like that. So divided by 4. And then to get out of that, you have to hit the over button. So you hit the over arrow, and it'll take you out of that. Now we want to get up into the exponent, so you can hit Shift 6. That's the little caret, the little up arrow. And then what do we want there? 15 times 4. So 15 times 4. Now that, oops, I'm going to stay up there. times 4. Okay, it's not letting me stay up there. So if you want to stay up there, you're going to have to put it in parentheses, it looks like. Times 4. So put that in parentheses. That little times is, I got that with shift 8. That's the asterisk. That'll give you the little time symbol. So yeah, if it's taking you out of the exponent, when you do that, just throw these guys in parentheses and it'll say that is my exponent. So there you go. There's your answer, 1,767 and 48 cents. And there it is, 1,600 or 767 and 48 cents. And there it is. That's all you got to do. We've got a little formula.